Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, I'll show you how to run large language models locally on your CPU based laptop. The reason for doing this video is simple. In the last few weeks, I made a lot of videos on running AI agents locally, running Claude Code locally for free. And in all of those videos, I see a common comment. Abhishek, can you explain how to run large language models locally on my machine? I'm using a CPU based laptop. That is, my laptop does not have any GPUs. So there is a way you don't need GPUs, you don't need llama. That's what I'm going to show in the video. When it comes to the system requirements, you need 4 to 8 CPUs and 4 to 8 GB RAM on your machine. That's good enough. And to make it simple, just like any other video on the channel, I also prepared a detailed notes, a detailed MD file that I'll share in the description. Perfect. So please watch the video and after watching, also try it at your end. Let's get started. So how are we going to achieve this? We will install something called llama.cpp or llama.c++. Now this is the one that allows the LLM inference on CPU based architecture. And this is free to use. I'll show you how to download and install this. Now the big question is, which models are we going to use? Now you cannot use any model because most of the models are designed to run on GPU based architecture. We will choose a specific format. Basically, we will go with GGUF models, right? I'll also share, some recommended GGUF models which can run on the CPU based architecture. And you don't have to worry. These works perfectly fine. They can answer your DevOps related queries or they can also answer your basic development related queries. And as I told you, I have documented everything in this MD file. So this MD file has all the steps, the model that we are going to choose, the system requirements, how are we going to install llama.cpp, how are we going to download the GGUF models, and finally, how are we going to run the models locally. I'll also show you how you can set up a chat GPT like interface for your local models. Cool. So now let's head to the terminal and start with the instructions. So the first thing we need to download and install llm.cpp. So if you're using, let's say you're on Mac, so you can just run brew install llama.cpp. If you're using Windows or if you're using Linux, just follow the MD file. You also have a specific commands that you need to run. In my case, I have llama.cpp already running. What I'll do is, I'll use this specific folder. I also recommend you to use a dedicated folder because in this folder, we will download the models and we will load the models from here. Okay, so we have llama.cpp, we created a folder. Now it's time to download the model. Exactly what we learned here, right? This is installed. Now to download GGUF model, you need something called Hugging Face CLI. So Hugging Face is nothing but it's just like Docker Hub. Within Docker Hub, you have Docker images. Within Hugging Face, you have a list of models that you can freely download. How do you install Hugging Face? So to install Hugging Face, you just need to have Python running on your machine. Let's say you have Python running, then using pip. So you can use this command, pip install Hugging Face underscore hub. Okay, so again, I also have Hugging Face.hub running on my machine. We can quickly verify by running hf-l. Cool. So the CLI is also here. Now let's download the model. So to download the model, just run this command. hf download. This is the model that we are going to use. So Quen models are usually powerful. So they are right now, they are trending local models. They are very powerful. You can inference them if you have a GPU based machine. Even if you have a CPU based machine, you can inference them, but you need GGUF model. So I'm using Quen 2.5, 7 billion parameter instruct GGUF model. This is usually 4 to 5 GB in size. So depending upon your internet speed, this might take anywhere between 10 minutes to 30 minutes. If you have better internet speed, you might even download it in 5 minutes. But yeah, so once you download, I've already downloaded it. So if I do ls, I have this GGUF model. Okay. So we are done with both the prerequisites. We have installed LLM.cpp. We also downloaded a GGUF model. Now it's time to load the model. So to load the model, you just need to run this command, llama CLI. But Abhishek, where did you get this llama CLI? When you install llama.cpp, it comes with llama CLI and also llama server. We'll first use llama CLI to load the model locally. There you go. So now the model is loaded. I can ask any question here. Explain Kubernetes. No? A very basic example to show you that this is working fine. And you can see the response. I have like somewhere around 20 to 30 CPUs idle. That's why my response time is faster. But even otherwise, you can expect a quick response on the CPU based architecture. How do you know it is using CPUs? I'll show you from my activity monitor. So from the activity monitor, you can see here right now, llama CLI is using 4 threads. As soon as I run some question, what is Docker? Okay, so you see the response and you will see the threads changing from 4 to 5. There you go. And as soon as the explanation is complete, okay, it also went to 6 threads because it is sharing a lot of information with us locally, as you can see. And once this is done, just give it 30 seconds so that activity monitor fetch the latest utilization. You will see this go back to 4. There you go. Perfect. So if you have more number of threads, if you have more number of CPUs on your local machine, the response will be faster. If you have less CPUs, the response will be slower. Abhishek, how can I utilize more CPU? Let's say if that is your question, you can pass the number of threads as well. For example, you can load your model this way. So this is the command, the same command that we executed, but this time -T8 represents go ahead and use 8 threads. Right now, when it executed, it was using only 6 threads. But I'm saying go ahead and use 8 threads. So depending upon your laptop, if you have more CPUs, you can pass that parameter. Okay. Now, using this command, you can run llama CPP locally. You can ask it to generate some shell script. You can ask it to generate, let's say, a Terraform manifest or AWS CLI command, right? But Abhishek, what if I want to use a chat GPT like interface? I don't want to use CLI here. Don't worry. Even that is possible. You can just run this command instead of llama CLI. Just say llama server and load the same model. Remember one thing here, the path that I'm using, LLM models. This is the folder that I created on my local machine. In your case, if the path is different, use the different path. Of course, even those steps are in the MD file. Okay. So now I'm running the llama server. This is the path. So I'll just copy this path. Okay. And if I just paste it on the browser, there you go. So you got exactly a chat GPT like interface. Let's ask a question here. Write a shell script to create S3 bucket in AWS using AWS CLI command. There you go. So you have the shell script that you are looking for. Similarly, you can ask for Terraform, you can ask for Kubernetes manifest, you can ask for a Docker file creation, whatever that you need. And most importantly, you don't need any API tokens. You don't need any paid subscription model. You can run this free on your laptop. I hope you found this informative. A lot of people ask me this. because a lot of you must be using a CPU-based architecture laptop. So that's why I did some little research. I used Llama CPP long back, maybe a year ago. But then, I had to relook at the Llama CPP documentation, see what has changed. Definitely the CLI commands have changed a bit. So again, I just prepared the documentation, the one that you're looking for here. I verified it on my machine and I made this video for all of you. So make sure you also execute the commands on your local machine and let me know how did it go for you. So once again, thank you so much. See you all in the next video. Take care.